Now, I don't have any fancy screenshot thing, and I ain't got time to mess around with it. This is a picture on a computer screen, as you can well see. This is what is generally known as a slicer. It is for cutting up this kind of thing, and I'll just spend 12 hours doing this. So basically, here's what you get. It's a box with some holes and some slots. Now, for instance, this hole here is going to take this switch. Anyway, your beauty. This thing here is an electric motor, and you can see the two holes here where the wires come through. That's where the slot is. The 4-bolt hole pattern there, that's the 4-bolt hole pattern, and then the single hole there is probably the wrong side, because that's for the earth there. But this has got extra protection here. This is a 4mm thick piece of plastic around here, so that should be good. So I am going to print that out. Now, the print time on this is amazing. It's down here in this corner here. It says 1 day, 3 hours and 23 minutes. Now, I've just done this thing here which says touching build plate. So I'm doing a support structure called tree, and that's what it looks like. So it's like a tree that builds its way up and then comes in and touches. I don't know if this is the, yeah, this is the way to do it. So then it comes in and touches the side here, and same up here, it just builds up and just supports that top surface there, which could fall down, and supposedly, obviously, it will, well, I should imagine, it will break off. I don't know. We'll find out. Now, there's two components there. You've got the lid, which is printing upright. I would have printed it on the base, but I don't know. I suppose I could move this all the way to one corner and put that into one corner, and then, but there'd be a lot of weird movements. So I thought to myself, well, I'm new at this game, that seems better to me, so I'll try it. I could have done the box, same as that with the tree support. This tree support looks quite wicked. And I ain't bothered about a little bit of face touching activity there, so that's 1 day and 3 hours. So I'm back on the CTC A10S, and the box is in bits again. The screen stopped working. So what happened, these are failed prints so far. So these blue ones are in PETG, and to be fair, that print turned out pretty well. It wasn't too bad. It was a bit stringy, as you can see from the inside. Let's get a look inside there. A bit stringy, and no, it wasn't warped like that, but it was fracturing. The walls on it were fracturing. So, and the stanchion here wasn't bent, and the holes were round. The holes were round. So I thought to myself, well, I'll try and bake it in the oven for a few minutes and see if I can anneal the plastic. And to be fair, you could see it's melted. It was worse than that, I can assure you. It was almost flat. And this was at the recommended temperature for PETG to reflow it. But obviously it would have been better packed in sand, or see somebody packs them in salt. So I might do that in the future, because the properties of this plastic is better. Obviously it's a completely unusable part now, But if I just try and crack it, you can hear it still cracks. So what I'm doing, I'm just cracking the side. Yeah. But before I know it, I had to put a little bit of pressure on it. Because my printing skills aren't very good at the moment, obviously. They're getting better, but it is not the best at the moment. And I'll have to go and look on Banggood and see if they do the screen combo, because I want the TFT screen really to go in this. I'm going to do that, but I'm not doing that. It's just, I haven't even done any mauling stuff yet, and I don't want to mess about unless I'm confident that I can do it. So anyway, setting up my netbook to run this, I had to run some drivers. I think they're called FTDI drivers that run these boards, and I could not get them installed with the VDC version, so I had to use the 2 something XX version. I can't remember, I was doing it last night very late, and it started recognising. Now, to get this ANET board to connect to the Arduino Uno, sorry, no, the Arduino IDE is a pain, to say the least. It's not in the board section, so and you can't download the board, so you have to install the board yourself. Now, if you had the 1.8 version, which I don't, I have the 2 version of the IDE, I think it would be easy, but they've changed the layout of the folders and the way the program's laid out on your computer. So I have disabled, manually by hacking the code, the files in the folders, I've disabled all the Arduino boards on my netbook, only on my netbook, and installed only for this ANET. And it was taking hours. I did it eventually. I just basically copied and pasted some files into multiple folders until it found where it wanted them. I don't know where it is, so I ain't deleted them. But yeah, it was the really old-fashioned way of doing stuff, just copying and pasting stuff and seeing if things work. That should be coming out now. And there's my PTFE. So that's the modification that I've made. I've put a piece of the blue Captain in there, and that was starting to melt because, well, there's no cooler over the heat break now. I don't understand why it's not coming out though. It should come out. Now it comes out. Don't ask me why. Anyway, I need to cool it down now because, well, that's to pieces. I really wanted to get all that plastic off of it. Can you see all that extruded plastic out the top of it? So where's that? Before I cool it down, let's get that out and get that off. Yep. Hang that there. Where I had put this piece of, let me get this plastic off, this piece of Capricorn PTFE tube in that all the way down, and it's very loose because it goes into that, goes into the heat break. And that came up so far, and then that little black washer on the top of it, and then when this gets tightened in there, whatever, when that gets tightened in there, that will push down that black washer, which will push this piece of Capricorn down in towards the nozzle and compress them. Well, I haven't got a PTFE trimmer at the moment, so the trimming of the PTFE wasn't going very well. But this is still 121 degrees. Let's just cool it down a bit quicker on the fan. See how quicker it cools down on the fan. Oh. So this is exactly the same setup as the other one. No problem. It saved me. I was going to make one of these heat blocks, and this was £8. So I thought, I think that's why I ordered this. I thought I'll order this anyway. This is UK stock for £8. Like that, as it comes with a silicone sock as well, which should stop some sticking. All I need to do is make this not leak. So I've got some 304 stainless steel 12mm bar, and I can make one of those out of stainless 304, which will be acceptable. I can put this in the lathe, and I can turn a taper in the end of that. So if I make one of these, instead of making the threads abruptly end like that, if I put a taper in the end of it, which screws down and seals into that taper, so instead of being two flats trying to come together and trying to seal two flats, which is going to be impossible without a gasket in between them, and I could make a heat-proof gasket to go in between them out of mica, which would work, but it'd be even more of a pain in the backside making a gasket out of mica just to put in that. If I take all my nozzles now and put a 90 or a 60 degree taper in the end there, and then make a couple of heat breaks, one for this one for that one, so the 60 degree goes in there and doesn't bottom out before it's met on the taper, both at 60 degrees. So I'll turn my compound on my lathe to the appropriate angle and keep it until I've modified all of those and made a couple of those. That should make these seal, especially if I lap them together. Then all I need to do is put another piece of Capricorn down there like that. You can see how it comes out the other end. Well, it will butt up against that. That's the idea. But to be fair, if I'm putting a taper on the stainless steel bit that I'm making, and that seals perfectly there, I won't need the PTFE to come down and attempt to make the seal there. At that point then, the one that I make, instead of putting a hole through it big enough to take the PTFE through it, I can just put a 1.9mm hole through the centre of that, and I can thin down this area, the next down area, a lot more, to stop the transfer of heat from the hot end into the cold end section. So that is the dehydrator. It is set to 60-65 degrees, and that's PETG inside it, the blue stuff you can see in the centre there. Let's go and have a look at the print progress. So we're here in the spare room again, and I have rebuilt the original hot end back how it was, with the Capricorn inside from the nozzle up to the black washer I made, and then the clear Bowden tube you can see is butted up against the top of that washer and held in place with the Bowden tube holding airline thing device. Now the only change I've made is, obviously you can see it's now got the black filament in, the PETG black, which was starting to make popping and crackling noises and wasn't sticking very well, and it was frustrating, so I tried the blue. The blue worked out the bag more or less, but second layer, useless. You know, I've got that print out of it there, that print just there, which I then put in the oven because it was very weak and cracked up a little bit, and then it melted and went everywhere. Anyway, white spaces, yeah, here on the steel, there's little white spaces in them, and all these spaces here will have to be changed around here. All of these here, all these white spaces, they will have to be changed and modified to fit these. Oh no, but those won't. So you can see that one there. See that little thin spacer? That's the difference between a good wheel and a bad wheel. So we've made those and put them in for cheap, crappy wheels. These wheels that are bought underneath, oh here's one here. There's one there. Let's go and have a quick 3D printing drawer. Hold on. So this is one of my tool drawers with next to my toolboxes, and here's the original wheels that came with it. You can see them. Yeah, I think you can see that the bearings are recessed, because this has got two sets of bearings in it, that's got one set of bearings in it. The two sets of bearings are way better, and they're all the plastic bits that I took out. Not required anymore. Anywho, with multiple different surfaces, they are different thicknesses. For instance, this Creality surface is about 141 thousandths of an inch thick, whereas that stainless steel surface just there is not. It's way thicker, it's about 20 thou thick. So you can see here on the table I have a gauge block just here. See it? Yeah, there's a gauge block just there. And then in this other pile of stuff, there's another gauge block, and it's just there, can you see it? Yeah, so that one corresponds to the glass bed, which is lurking down there. So, yeah, I can't point at it. Underneath the steel is the glass. And that's a different thickness to the Creality glass. So I am planning on, right here, on the Z-axis switch, to make an adjuster, but I want to put an automatic bed leveling probe on this head. That will eradicate that Z height switch there. The only problem is you've got this BL touch thing which I'm looking at, and the other ones, they're all very bulky, and I want my let's keep it stop. I want my bed height sensor to be within a centimetre or so of the nozzle. That's what I want it to be. So you can see on that circle it's left, it's a couple of turrets. That's fine, as long as it doesn't affect the print, I don't mind. There's a couple of strings, not many. I haven't changed any settings at all from this print. From last time it was stringing everywhere, and there was holes, and it was peeling up, and it grabbed it and ripped it off the bed. I've just set it going, and all it's leaving is those little turrets there, which you can see. Oh, come on, focus in, boy. That there. No, you can't see it. There we go, you can see it. Those little tip pits there. Hopefully they won't affect it that much. But that's it. It's changed shape. Oh no, it's peeling as well. So this is where it peeled before. You can see the peel just here. I'm going to leave it. See if it can continue. I think it will. Once that spine down the centre's got good enough. It's very disappointing. Everything I'm printing is quite big. This is going to be a draw liner for those drawers that you just saw. As you can see, it's printing a tree style support here, because this will be 370 millimeters high. That's 300. So you can appreciate 300 is 12 inches, 70 mil is just under 3, so that's 15 inches. It's going to be 15 inches high. And it's already started peeling off there. I'm not going to touch it because hopefully it will just compress that little bit in the corner there. Make that hinge bit, if I can show you the hinge. No, it's going to get in the way, obviously. Oh yeah, well in the way. Maybe you'll see it there. You'll see a hinge bit there, yeah, just about. See it at the back there. There we go, you can see the hinge bit. So that'll be like a round hinge bit. And the second layer of this drawer thing. Oh, please stay on. I'm really tempted to stop it at that, but it's been going 2 hours and 8 minutes. This is a 27-hour build at the speed I'm running it at. 100% infill, 3mm wall thicknesses, and it is peeling off. I might put some weight on it. Let's put some weight on it and see if it holds it down. Alright, calm down, calm down. And I'll get some more weights and put it on it and see if it'll hold it down. Because I am getting sick and tired of things just peeling at one little bit to ruin the whole thing. What that little zoom is, I don't know there. Anyway, the previous go at that was that. Let's put it in there. You can see that there. And that started destroying itself there and peeled here. And then that was turning out really nice. That's the thing. And it started peeling, I think, well, you can see the dangly bits. And it also started rubbing. I don't know why it started rubbing, but it does. It starts rubbing on this one for some reason. Apparently there's something about the Z height gets bigger, so I might have to put some Z height tolerance in for printing these thicker bits. It's a mystery thing. I'm going to get some more weight and put it on there, and now I'm going to put a piece of steel on there or something to hold that corner down. Okay, fingers crossed, that will do it. I've got 4 weighty pieces of steel, and it's just above the height now, where they're going to be safe. So I'll let that run for about another hour and see what it comes up with, see if there's any layer shifts or anything like that. I'm expecting it to be good. It's not running too fast for that amount of weight on the build plate. In fact, when I make the new heated bed, it will be about that much heavier, I should imagine, because it's going to be at least twice as thick aluminium sheet. So I haven't even cleaned the bed. I'm getting naffed off cleaning this bed for no reason because it just doesn't stick. So I've left it as it is after the last print was on it. I've turned the print round to 45 degrees, as you can see. I have took the roll off of the unit, the filament roll, I don't know if you can see it in there. It's now on top. I don't think you can see it in there. It's on top of the thing, a bit like a sidewinder. So on top of the box here, there is no filament, it's all inside. I'll be able to see it better now, I don't know. You can see it in there now, I think you can see it. No, maybe a little bit, I don't know. Anyway, it's on top of the frame there now, the whole thing's bolted on. So we're going to get some vibrations. To counteract the vibrations, I have made these, I haven't made the brackets to fit them yet, as you can see they're not fitted, but they will go at the back. so I don't knock them and they don't get in my way when I'm doing stuff. The 45-degree things that come down from the front, to me, are just going to get in my way. So I've made 90-degree ones which aren't as good as 45s, but they'll still give a bit of stability, and I will fit those way up. Just a more layer change. So that's the most promising it's looked so far. I think we're at Z height is 1.5 millimeters. It's doing 0.4 millimeter layer heights. I think the first layer height's a little bit less than that, so this is probably the fourth layer, and it hasn't even attempted to start peeling yet. Okay, so I've put some black PET G back into the dryer, ready for tomorrow's attempt. So you can probably see it already through the hatch. Let's grab over that. Oh. And there she is. The next failed attempt. Let's put it down there so we can get some light on it. So there's the texture. And as we can see, it's a very consistent first layer. Well, as far as I can tell. I haven't really looked at it yet, I've just come in here and picked it up. Lots of stringing. Not to worry, I wasn't really bothered about the stringing. But it started peeling up. You can see the edge. So it started peeling up around about third layer, fourth layer. I thought I'll leave it, but it's just become a banana. It's just a banana. It's absolutely ridiculous. It was printing beautiful, straight as a die. Man, if I could just get it to stick to the bed, it would work. Oh man. So anyway, I've crunched up the vent. Now I'm not doing it again tonight. I've had enough stress. I think I'm going to re-slice it. I'm going to pump the bed temperature up to 90 degrees centigrade. At the lower temperatures it just comes straight off. So I'm going to pump it back up to 90 degrees centigrade on the bed. I'm getting a lot of string in. I don't know if that's too cold or too hot with the hot end. I've got 6-7 millimeters of retract and 5 millimeters of withdraw, whatever you call that, I can't remember what it's called. So the extruder here will withdraw 7 millimeters, I think it is, and the head will lift 5 millimeters before a movement. Right, I was getting very annoyed, so I took the Creality bed off and I put the glass bed on and I coated it with glue stick, yes, with decorating as well, original Pritt stick, and I watered that down and smeared it around. This bed of stick, I'm getting very sticky about these things not sticking. So it started again. Ooh, it's frustrating. Now you can see the odd shaped angle of the glass and it just fits on. And you might be able to make out the streaky lines of the watered down Pritt stick, PLA glue, whatever it is, PVA glue. Now I'm running the bed at 90 degrees, as the thermistor says. It won't be at 90 degrees. We've got the head, the print head, at 240 degrees. I suspect that's under reading slightly on the temperature. And this PET G that I've got here likes 240 degrees as far as I can see. A little bed levelling. There was a bit of mis-extrusion there. It's cracking. I think this PET G is a little bit wet now. It's been out for about 5 days. 6 days. So this may be a failure due to wet filament. Great. Or damp filament, shall I say, because it's soaked up moisture from the atmosphere. So I've been consumed with 3D printing now for the last couple of weeks, and last night this is what I was getting. Very nice glossy surface, sticking, not bad, but then starting to peel at the end. Just you see the end there, it's just curled up, just starting to peel after a couple of layers. So I dried this black PETG, and I decided to up the temperatures a little bit to 245 from 240, and the bed up from 90 degrees to 98 degrees, and it just wasn't sticking here, and under extruding, I think. Good grief, what a mess. Anyway, you can probably hear in the background with the little that the lathes now warming up. This is just beyond a joke. Absolutely beyond a joke. Hopefully when the BL Touch system comes and I fit that and get that going, things will be better. Right, back to something I'm more comfortable with. I'm fed up with 3D printing, I can assure you. If I'd have got one part come out of that 3D printer so far, I wouldn't have been too upset. But I am livid. Absolutely livid. And I've got a piece of scrap aluminium. Complete and utter scrap. Yeah? But it should do what I want it to do. Right, so I've finished off the other side. It isn't perfectly concentric. It doesn't need to be. So this flat will be replicated on this side. Just about exactly. I've got a 24.9, 24.7-ish boss there. I'll give it a really heavy chamfer, as you can see. And it's still a mystery as to what it is. So I know you're a bit shaky up here, and also there's a bit of the unpainted toolbox in the way, but you will get to the gist. And also I'm working on the cam lock pins for the whole book again, so I'm just making a template, so you might have seen that. Now I've got to cut a 1-pitch gear. You can't see it. I've put the aluminium spigot bit in the full jaw, and I've got to cut 1-pitch threads on it. Now I don't know if you can see this. Yes, the digital scale's there. I've already checked it. It is set up at the present for cutting 0.25mm pitch threads. You might have actually heard that. It's going dig 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 dig. And then be careful to tighten this up the correct way and not the wrong way, otherwise it will fall off again. So nip it even tighter, and usually when you nip it a bit tighter, they either go tighter or looser, and in this case they've gone a little bit looser, which is good because they were a bit tight. And that's the gear setup. So you can see the gauge here, you can see maybe number 1 there. So if I turn around that, one more whole full rotation, there she's at the top again, and that's more or less 1mm. So that'll be cutting 1mm pitch, and obviously there's the part. Oops. And I'm going to be putting threads on this land here. Alright, I have fitted a light inside. I've changed materials to PLA and I am printing trays for my Bizzle drawers. So that'll be, well, these. There's 2 trays, front to front, being printed. The best I've got so far, I chucked it on the floor yesterday, I can't be bothered to go around and have a look at it. It's the one that you've seen with all the squiggly bits on top when it let go. At present it hasn't curled at all, so PLA, you expect it to be okay, but this still is a very difficult print. It's long and thin. Right, back to something we know good. Working on the lathe. So I'm squaring up this round stock, as you can see, and that is going to be a new hot end for the 3D printer. I'm just going to get the other bit and I'll show you how it sort of goes in. So here is the cold end of the hot end, as you've seen me make earlier on, and that will be fitting in there. As you can see, that square block is a little bit too big for that. The front end of this is 30mm, this is 27mm. So this is going to be where the fan mounts at 30mm. Then there's going to be the small cone section, which is rounded. It's going to be square for a start. Then it's going to be sort of tapered down from a square to a round section, down to the 27mm and smaller. And then there's going to be a 27 by 27mm square block back here, with a hole drilled through from the top to the bottom, all the way through at that diameter. And then about 4mm in from the top and 4mm in from the bottom. It is going to be widened out inside so the air can get past the fins and the fins aren't touching the outer wall, so it's good circulation. Then there's going to be a row of 6 holes down either side at the back here drilled through, and that's the exhaust, so when the air's gone through it's got somewhere to come out and not go down towards the hot end section. There's going to be another exhaust, 2 exhausts at the top, shooting air out the top, although I haven't decided on a final decision for that yet. And there's going to be holes drilled and tapped all over the shop, so things can be attached to this for the cold air injection system to cool the part for bridging and stuff like that, and then the cold air in and the hot air out exhaust assemblies to get it out of the enclosure, and other bits and bobs as well, just circum bolted bits. Oh yeah, the touch system, the bed leveling system is going to be bolted to this as well. It might actually be passing through this system, and it might actually be passing through that as well. There might be a hole drilled through that with the touch sensor going through that and going through the hot end to get it as close to the nozzle as possible. There she is. I am up to, where are we at now? 98mm. Yep, it's 300 and something millimetre, I think it is. Shouldn't it be 270mm for an A4 piece? I think it's 320mm height this will be eventually. That's the height of the Bizzle drawers. And the tree's printing the best, the internal tree, the tree inside, so the tree support structure, shall I say. There's no tree in there. Inside there you might see the tree support structure a bit close. You can actually see it's underneath the head at the moment. And the bit in the centre is printing, well, the bit in the centre, the inside of the bit in the centre is printing smooth as a baby's bum. Now the outside of that isn't it stringy, but not to worry. The sides are looking straight as a die, but it is PLA, and let's face it, the CR10S or the CTC10S this is quoted as being able to print PLA and ABS, and it does PLA. To be fair, everything I've done in PLA, once you get it tuned in, doesn't cause problems. Alright, you'll see it when I'm seeing it. I've just come home from work. I know it isn't perfect because I checked it this morning. And that's what we get. Just turn the light on in here. If I can. I think it's on. It is now. There. So it printed well up to about this stage here. And then I came down and checked it before I went to bed last night, and it was up to about here. And it was still in one piece. Now I woke up this morning and it was up to about here. And it had cracked here and cracked here. I didn't know the full extent of it. It's still stuck to the bed. Oh yeah, it's still stuck to the bed. Well, the tree is anyway. The tree is still stuck to the bed. Yeah. I don't know if it's going to come off. Oh yeah, okay. Okay. Well, the tree's falling off of it anyway. It does tend to print these trees pretty well, but they're still not all in one. I think it is recoverable. So I'm not going to be able to get inside it with one hand. I'm going to have to break it open and we'll have a look inside it. So this is the tree structure inside. I'm not sure if it's come off of this alright. Oh, it might come out. There we go. Look at that. It's like a manifold. Look at it. That is awesome. If it had just printed it perfectly, because it hasn't printed it perfectly there, if it had printed it perfectly, that would be a mightily great decoration. That is awesome. I am keeping that. I like that a lot. That is wicked. Look at that. Yeah, I'm liking that a lot. That is magnificent. Now the computer came up with that structure. I'm really upset that it hasn't printed it beautifully. I really need to set the printer up better. Anyway, so this one, not bad, eh? Not too bad. Not too bad at all. It's just a draw liner, you know? It's just to stop things touching the metal at the bottom, and it's going to do its job. There's a bit of cleaning up to do. Now I may grind some salt up and try and salt level these, anneal them. But I may just plastic weld them. This one's cracked obviously, quite severely just there, and a little bit just there. It's re-welding itself back together again, that crack has at the top here. So it's come to pieces there. Yeah, you can see that there, and it's re-welding itself back together again with the heat. Yeah, not bad. Considering what I was trying to print, which was those two vertical, and the bed moves. So they are that tall and we're flapping around. So there we are, it's a draw liner. Clearly it needs spacing out, but the idea of this draw liner is it will have a spacer in front of it, spacer in there, and then it'll be pushed up so it just goes underneath that lip a little bit, and then I'll force spacers in the back here, and it'll be situated like that, and hopefully more solid. And then if you look in the back of the draw liner there, can you see that? Oh yeah, it's like a hinge. So I know these drawers are only very thin, but I'm sure you can appreciate that if you just put a layer of pens in there, it's a bit of a waste of a drawer. But if you could somehow have a hinge system and have a flap which lifts up and comes back down again, you could have a row of pens on the bottom and a row of pens on the top, and if you want to get to the pens at the bottom, you just flip up the flappy thing. That's what the idea of this was. Now, I think it's overkill for what the 3D printer can do, and to be fair, if it was capable of printing that out perfectly with not a problem, they would be worth £17 a pair. But it can't print them out perfectly, so they're not. So I'll go back to what I've done with the other drawers. So in some drawers I have put in 6mm plywood and glued 6mm plywood in runs like that, and you'll see that in quite a few. And as you can see, it's very useful. You can fit many different sorts of things in these drawers. What else have we got down here? So I've got a bit more segmented than that. Segmented, that was the one I'm looking for. Again, a bit more segmented in that one there. And, you know, it's amazing what you can fit in these drawers. Simple drawers like that with no segmentation. And then I've got these which 90-degree angles, and I've just glued all of those together. Got a few drawers like that, they're not all together. I've got just open drawers like that. Then I've got these which are thicker 12mm plywood, 12mm ply, and then I've routed loads and loads of lines in them for taps and other things that can fit in there. And quite a few drawers like that. Again, they're not all together. You know, it's quite amazing. There we go. So I just sat on the table saw one day and then cut loads of these out. I mean loads. I've got loads of them. Some of the drawers are stacked with them, and I've got other bits laying about. They're just normal drawers. Now that was that side. That was all plywood. And this side, I was getting a bit naffed off with doing the plywood, so what I started doing was getting this mock leather and then just cutting the mock leather out. Now the problem with the mock leather is getting it to stay in the corners, because it likes to go out once, and I'm not sewing it. I can't bother to sew it, so a lot of these are just put in and the tools are heavy enough, but some of them the tools are not heavy enough. Oh, there's one other stuff. So I've just jammed in, they're not solidly in there, I've just jammed in pieces of wood just to hold it in there a bit better. And that's just you see how loose that one is, it's pretty loose. And yeah, there's bits on the floor and all sorts of things. Let's have a look. And then, you know, nothing in that one. Oh, there we go. And I've got some plastic on the 45s. Doing it with plastic, and I've done it with wood. And some of them, I haven't done them all, some of them just aren't finished at all. You know? There you go. There's one with the mock leather and the wood at the side, just to hold it in there a bit tighter. They look better, to be fair, because when it's like this, it's all just loose and saggy. So in conclusion, I think, I don't know whether it's conclusion or not, it's been a long time since I've done a video. Anyway, I've made this. Can we see it? Sort of. The lighting in here is really bad. Well, we could put some more lighting on, couldn't we? And you could see it. There we go. Now you can see it. So it's starting to look like the object now, isn't it? That is the cold end of the hot end. It's a bit of a tight fit. That looks similar to the normal cold end of the hot end. That's my fan holder. It's a light press fit, and it's going to have that silent fan on the front of it. An ever cool silent fan. So there we go. That was all done on the lathe, by the way. the lathe is making the 3D printer better. And if you look at all the little bits inside, oh, yes, you can hear me take it to pieces. I think maybe, if I turn the light back on again, you'll be able to see all the lands inside. I don't know if you're going to be able to see them or not, but there's a counter bore inside, so it's 22mm here, and you might be able to see inside there. There's an extra 3/4mm to get air around the fans and the fins and through the fins, and of course there's going to be exhausts, or a single big slot exhaust down there and a couple more exhausts up here, and then 4 holes here for a clamp just to hold it in, 4 holes here to hold the fan on, 4 holes here and 4 counter bores in here to hold the things, and then the thin tubules going down the side is going to be part of the part cooler system. And I'm happier. I'm back on the lathe and I've made something that's going to work. Still got a millimetre on that face to take off and a millimetre on that face to take off, or thereabouts, and I've still got a millimetre on this face around here to take off, but the back face, thankfully, it's in good nick because it was a gamble. It could have turned out like that face there with a great big pit in it and a couple of chuck marks and what have you in it, but it didn't. It turned out good. And the front is perfect, and the taper and that wall thickness, I've measured it as best as I can with a caliper, is around about 1mm. So it's about 1mm. And it weighs not a lot. I've weighed it, I can't remember what it was. Was it 54.6 grams at the moment. It's going to be lighter than that once I've took the exhausts out of it and drilled some more holes and tapped them, and drilled some more holes here and tapped them. And I haven't followed this design perfectly, so you'll see this hole in the centre here isn't as big as the hole that's in this one, because the aperture was the first thing up the side here. The inlet aperture was the first thing I drew, and I was using whatever you call them. I can't remember what you call them. What was I using? I was using this thing, loft. That was it. I was using this thing called loft, and I don't know how to use it, so it didn't turn out how I wanted it to turn out. But there you go. I've made the part the way I want it. Looks pretty cool from that angle, does it not? Now, here, these bolts here, so there's 4 of them, M2s. They won't be protruding, they'll be flush, they'll be flush at the bottom, they'll be countersunk in. So there's just some things that I haven't done here on this drawing which will make it look a lot cleaner and better. Well, there you go, there it is, it's coming along, it's nearly ready.